Hello everybody, my name is Ajeng Maharani Putri. I'm a bachelor student at University of Indonesia in Department of Mathematics. And now I want to present about acute sinusitis data classification using Rayworth optimization based support vector machine for 2020 first conference on Internet of Things and Embedded Intelligence or CITEI 2020. Here are the outlines that I will bring to the presentation. First is introduction, then dataset, methods, results, and conclusion. The first one is introduction. Sinusitis is one of the most common health complaints as well as one of the main causes of antibiotic prescriptions. The main causes of sinusitis are most likely due to viruses and other factors such as allergens, irritants such as smoke or dust, fungi, and bacteria. Acute sinusitis is the main manifestation of sinusitis, which causes inflammation and swelling of spaces inside the nose. And here we can see the difference of healthy sinusitis and acute sinusitis. They are different. There are several methods in diagnosing sinusitis, such as computed tomography scanning or CT scan, nasal endoscopy, nasal and sinus culture, allergy test, and the last one is magnetic resonance imaging or MRI. In this research, the data attributes that will be used for classification methods came from CT scan data. The next is dataset. Like I said before, the dataset used in this paper are from CT scan data that we get from Department of Radiology at Cipto Mangunkusumo Hospital at Jakarta in Indonesia. There are 5 variables. One of them is a dependent variable and the rest of them are independent variables. The first one is gender of the patient, 0 for male and 1 for female, and then age of the patient, and then Hounsfield units, where Hounsfield unit is a relative quantitative measurement of radio density used by radiologists in the interpretation of computed tomography image. And the next is air cavity, and the last one, the dependent variable, is diagnosis. In the diagnosis, the patient with acute sinusitis marked with 0 and non-acute sinusitis marked with 1. The next is methods. In this section contains 3 explanations of methods. There are Rayworth optimization, support vector machine, and the last one is Rayworth optimization, support vector machine. First one is Rayworth optimization. Rayworth optimization is one of recent meta-heuristic methods which, inspired by Rayworth or Canis lupus, proposed by Mirjalili. Here is the picture of Canis lupus. The Rayworth optimization algorithm simulates the leadership, behavior, and hunting mechanism under the Rayworth hierarchy in the term of movement strategy of search agents. The population of Rayworth consists of 4 hierarchy, that is alpha in the top, beta, delta, and omega. To simulate the leadership hierarchy of the Rayworth, consider the most suitable solution as alpha, and the second are beta, and the third are delta. And the rest of the candidate solutions are considered to be omega. And here are the mathematical model of behavior of gray wolf. So during the hunt process, the gray wolf encircle their prey. Mathematically, the model of encircling behavior is modeled by the equation below, where T is the current iteration, A and C coefficient vector, D vector of encircling prey, X as position vector of gray wolf, XD position vector of the prey. And the coefficient vector A and C are calculated as follows, where the component of A are linearly decreased from 2 to 0 over the course of iterations, and R1 and R2 are random factors in closed interval 1 to 0. Next, the first three best solutions obtained so far are safe, and other search agents are obligated to update their position based on the position of the best search agent. The formula is defined by equation below. To terminate the gray wolf optimization computation depends on the convergence to the optimal solution needed. In the case, if the solution doesn't have a constant state, then to get the solution is by terminating the update process after the maximum number of iterations mentioned is reached. So in the program, the first thing we have to do is determine the number of iterations that we want. The alpha score that obtained from the calculation is the best solution, and the corresponding alpha position is the parameter that will be evaluated obtained from the search space. And next is supervector machine. Supervector machine, or SVM, is a classification method introduced by Foster, Guyon, and Papnik in 1992. The SVM method is widely used in bioinformatics due to its high accuracy and is able to handle data with high dimensions. The main idea of SVM is to find the hyperplane between two classes, here two classes of data, and maximize the margin, here is the margin. Supervector machine use linear model as decision boundary with the formula here, where the W is the weight factor and B is bias term. Define the hyperplane before. R become this equation, and the output form is like this. And the value 1 if the equation greater than 0, value 0 if the equation equals to 0, and the value -1 when equation smaller than 0. Here are the margin, is the hyperplane, and is the two classes of data. And in this study, the kernel function that will be used on SVM is RB of kernel, where the kernel function is like this. And the last explanation methods is gray wolf optimization support vector machine. Based on review from Faris, Bajarah, Albetar, and Mirjalili, one of the applications of gray wolf optimization is to find the optimal parameters on SVM. To maximize the SVM performance, the parameters must be tuned, the error penalty C and the kernel parameters. And here is the flowchart of gray wolf optimization supervector machine. First, we have dataset. We split into two that are training data and testing data. With training data, we're going to find the optimized parameter. But first thing we have to do is initialize the gray wolf population or number of search agent and number of maximum iteration. Then we calculate the fitness evaluation. And in this study, I'm using the value of accuracy to be fitness evaluation. And then we calculate X alpha, X beta, and X delta. And then update the position of the wolf with equation here. And then update the value of A, and then coefficient factor A and C. And if the iteration hasn't reached maximum iteration, go back to the fitness evaluation and do the process. If iteration has reached maximum iteration, we get the optimized parameter C and gamma. And then with the optimized parameters that we get, we are going to do SPM prediction, and then we get the output. And the algorithm will be end. And the next results. Here are the results. The performance of SVM, RBF kernel, and gray wolf optimization SVM RBF kernel was analyzed using the Python programming language with different percentage of training data, which start from 10% to 90%. And this is the result of SVM RBF kernel without gray wolf optimization. And these are the accuracy from training data from 10% to 90%. And then this is the optimized parameter C and gamma that we get from gray wolf optimization method. When training data is 10%, the C we get is this, and the gamma is this. And then we use this optimized parameter into the SVM RBF kernel. And here are the accuracy that we get. And this is the comparison between SVM RBF kernel without gray wolf optimization and gray wolf optimization SVM RBF kernel. We can see the result that the proposed gray wolf optimization supervector machine approach outperformed the SVM algorithm by optimizing the input parameter of the SVM classifier. We can see the proposed method has greater accuracy than SVM without gray wolf optimization. And the conclusion are the proposed method produced the lowest accuracy of 98.33% data training at 70% and achieved the highest accuracy of 100% when data training at 10%, 20%, 50%, 80%, and 90%. The comparison result on the previous page illustrate the effectiveness of using gray wolf optimization to turn the parameters in SVM classifier. However, the difference in accuracy results are not very significant because using SVM without gray wolf optimization already provides good accuracy results. So for future research, this method can be used for other data with expectation that the accuracy of the classification result obtained is better than just using conventional methods. And here are the references that I use. And thank you for your attention.